well, maybe he can tell you more of the student things you need to know, if you need to know, and well, this is the first time for him. First, I'd like to mention that actually, I think I understand why some of you were joining incorrect lesson this week. It's because this link is not the same as this. I will put this meeting link each time for our course, and you can see that here these digits are different. Yes, so make sure that if you use this link, you actually click on the correct one. Alternatively, as I have said, you can always join from Teams itself, or sorry, activity, Teams. Yes, from the Teams itself here. Which way is more convenient for you. So I have also uploaded an additional function file for our program, which we are going to need today. Because not recently, but last year, some students were having issues with additional packages, yes, especially if they were using Mac OS computer, and that just didn't work regardless of anything what we did. So including this file actually helps it. If you are using MATLAB, you don't need this file at all. If you're using Octave, then you might need this file, and it's more convenient. So let's maybe start fast with this Octave program, how it's working and so on. So after you launch it, here you have your files where you can work with your programs. Here you have workspace where you can see the variables which are stored in your program. So we have defined here two variables, x and y. Both were vectors. Yes, has multiple elements called arrays or something like that. And you can see them all here. Yes, including their actual values. So this is command line window where you can actually, make some calculations, input some commands. I can, for example, calculate sin of the x. Yes, I can calculate cosine of the x, anything you'd like. So any command can be input here. Alternatively, we can write a script, and I recommend you doing that and save it and run it from your computer. So first thing you need to do is to actually select some folder which you will work with in your practical exercise. So I have already created this folder in our course folder on my computer. Now I'm going to open it here in the Octave. Yes, I have many courses. This one is particular we need. Yes, so you select that folder, press select folder, and now you can work within this folder. Now I'm going to make a new file, and we can start working. Also, you need to put this file from here, if you are using Octave, into that folder. You can do that by saving it, or you can open this file, copy its content and make it here, yes, and then save as AWGN. So basically this is additive white Gaussian noise function we are going to use. So this way I have saved this file. It's a function file, it cannot be run directly. So if I press run, you can see that there is an error. It cannot be run like this. So you need to actually include it in other files. So you will do it like this. You will make a new file. For example, it will be, I will save it at once. We'll name it like exercise 1. For example, you can choose other names, but be certain that you don't use spaces, because spaces cannot be allowed. Be certain that you don't use a number as the first symbol, because that also will not work. It will give some errors which are not related to what was happening. It will misguide you with these errors, but the fact is that the file name has to start with a letter and cannot contain spaces or dots or other symbols, except maybe for this underscore symbol. Yes, this one can be used. So here you will write your program gradually, and that program can be executed. So, for example, the same plot x logarithm decimal of y, and red crosses sorry, red crosses. And then I can execute this program at once without needing to type this line again. If I need to change something, okay, what's happening? I think I'm putting one more bracket than needed. Yes. So if anything works incorrectly, you will see it here in the command line. For example, in this particular case, you can see syntax error, and it points, in my particular case, directly at the problem, that this was the bracket which was not needed. In some other cases, you can have different other errors. For example, I will put here x1. I never told Octa what is x1. Yes, I don't have x. And if I try to write this program, it says x1 undefined. So this means that there exists no x1 in your program. So you need to actually, for example, say what is that x1, like this way. X1 will be X. Now, I'm not sure if you had any MATLAB or you didn't have, so that's why I'm making this brief introduction to you, because we will rely heavily on this Octave and MATLAB in our course. And now it's working. Yes, so graphic is displayed. Let's see it again. Yes, so it's being drawn. Okay, so this is such a brief and introduction. If you will have any questions on Octave, please feel free to type them. I will be also here at the practical exercise. But now I'd like to introduce you to our doctoral student, Tianhua Chen. He is also foreign student, yes, and he will accordingly work with you on practical exercises. I will also be here. I will answer any questions also if these questions will be difficult or something doesn't work or anything like that. So I will also follow you. So yes, please, Tianhua, you are welcome to take off.
Thank you, Dr. Enes, and good morning to everyone. And my name is Tianhua Chen, and I will be your lecturer on the practical work part. And let me show you my screen. And first, I want to introduce about the author's information. And in this course, and we will see some guidelines for the practical work part, and Dr. Enes will upload it before the class begins. So let's check it and download. And here we will see some introduction regarding what we will do in the practical exercise. And for the first practical exercise is regarding the digital signal receiving with the adaptive white Gaussian noise. And for the proposal, which will show the basic principle and creating the MATLAB simulation models for the transmission simulation in the channel with noise. So here we can see there is no individual parameters with system. And when we finish this report, we will you can send to the Dr. Enes his email, and some contents will conclude in the following, and you will answer about the objective of the practical exercise, and you will attach your full source code of the simulation programs, and what kind of the figures or plots you how can you obtain it during the simulation, and some conclusions on the noise immunity of the to compare the modulation types. And there are also some tasks which will need to be solved, and I suggest you can remark the first task to the a task, and from each task, what do you get, and what's your comments, your conclusions, you can write in your report. Here is next part is the basic guidance for the practical exercise. And let's switch to the Octave. So, and for the Octave, and Dr. Ennis already introduced some basic components. And what else I would like to introduce for the adaptive white Gaussian noise, and we can check the package. Do we have it or not? And the package list, and we can see this one package communication, which we will use. So, and there are also some command window and documentation, like function index, like you want to know how to use the like sign function, and you click it, and it will show how to use it. It's very convenient for you to search if you don't understand what kind of the functions, and the variable adapter is here, and I will comment the windows, and also write the file. You script file, and you can save it and write for it. So let's get started. So we will read the task. So first task, we need to choose a random sequence of the 1 and 0 binary symbols and display this discrete process as a plot. And we can read the guidance for the first task, and the initial data can be manually selected and stored in the vector, and pick a total of the 10 values, and we can type it by ourselves manually, like s equal to the and 1 or 0 1 0 1 0, and it will show like this, and we can find the verbs. Workspace, yes, workspace, which we will type the variables here, and you click it, and also can see the details in this one here, and we go back to here manually. But I also want to introduce about automatically to generate the random values. So we can first we will need to how many values we will choose in this like in the initial data, like we need, and it says we pick a total of the 10 values. So we suppose the n is the 10, and 10, and we will get 10. And next we can generate the random indices, like we use the random 2 and 1. And we can see the random indices. They are all the 10 values, and they are all regarding the 1 and 2. It will only can start from the 1. So, and this is not our wanted. We need the 1 and 0. So we can create a small array, like array equal to the 0, 1. Then we can get the final array, like so. We get this one. L is near. Okay, it's something is wrong. That's the Y. So we can get this one, and the list of the initial data, it's generated successfully, and they all contain the 1 and 0. And we also can save it as the script. Let's do it, and equal to 10. We can command this one is the number of the values in the way, and int, which will equal to the range. We comment this one is the generate random indices. And we will create a small way for equal to the 0. Then we can get the final way. Will be the final way. So we can save it, and first time you will use this button, save file and run file. First time you will save it at which the part you will want to save desktop, and like first we name it as first practical work. And you can contain your student ID, your name, like that. I can save it. Okay, you can. Yeah. And let's go back to the values. And for the part, we will visualize the data, and there are some different plotting functions can be used. First, I will introduce the Steam function. Let's see what will looks like. Steam as
I'm sorry, but maybe you can do that in that file, which we
okay.
made later. But it's better because you can change something and. Well.
Yeah. Okay. And you can see the here, and from we have the 10 values, and for each 10 values, it's different. Like for the first value 1, it's represent 1, and the 2 and 3 there is 0, and the 4 is the 1, and so on. Now we can save it in the script. So we can like plot multiple figures. We will not lose our figures. So we named it as figure 1. And Steam. Yes. Then I can open the grade on. That will be the plot, the discrete. Then we can use the other plot functions like stairs, STA, stairs, or stairs also. And we will looks like what it looks like. Oh. Okay, it will connect them together like 9. Can see here, but why it looks different with the previous photo, because we will randomly generate the values here. So it will, each time you will write, it will be different. And we also can use the plot function. Let's see, we just copy here. Plot function. Yeah, it looks like that. We'll have some 9 line together. It looks like a pulse. So the first task we will we haven't finished for the first picture. You can see here some labels, and we must we can add them, and like for the labels we can label them. So for the X is the sample number. For the Y label, which is the sample values. And we can also make it how to say it's can looks like this one, and we have label, and we can make the x and the y extra bigger, and then we can see what it looks like. The y. And the minus 0.1 to the 1.1. So yeah, like that, we can make it a little bit. So the first task we already finished, and use this one. You can make your own comments here. Use this function, this symbol, and let's go back to the second task. We need to convert the discrete single to the unipolar pulse with amplitude 1 voltage, and we also need to plot the results. And for the guidance, it can see the in order to transmit the signal of the communication line, it must be converted into the analog signal, which means to the modulated, because usually we plot the signal in the octave. That will be the digital signal. So we can use some method to simulate it as to convert to the analog signal. Like we can use the 100 times to make some a factor of the single continuity, and it will show in the picture below. So let's try to do it. And okay, and there are multiple ways, and for the most straightforward ways will be the Cronk multiplication, and it's like a matrix multiplication method. First, we can generate some vector, like use the one vectors once function. We can see here. We use we suppose SC equal to the once. And we can see the X wheel, SC wheel looks like this one. We generated only these elements is one vector, and it only has the row vector. We will save it to the secret, so we can comment that the second task. See, second task. We will one. To like pattern it will be the pattern and the representing the constant level of the to the analog single, and we can use the Cronk multiplication function, and if we not familiar with it, we can search from the function index, like from this one function, and it will shows how to use it. A, B, and it's basically it's like how to say matrix multiplication method. It can be used. So, and we can see here we define the transmit single as the S. And do it here firstly. Transmit single. Use the Cron matrix multiplication method, and the S will be our S, which is S will be our data or symbols. Yeah. S and SC, which will looks like. Okay, we will generate this one, transmit single. So you can see from the dimension S multiplied to the SC. So 1 multiplied 10 and multiply with the 1 multiplied 100. Then we can get 1 and 1,000. That's save the secret. Save the the functions in the secret, and TX Cron S and SC.
So
Then
yes,
we can.
Sorry, here I'd like to just comment
Okay.
simple that basically what cron does, it replaces each element of those ones and zeros with 100 versions of them. So it copies. Yes, you have 100 ones, 100 zeros, and so on. So basically, just to speak simply, what does it do? It actually repeats each symbol in our particular case 100 times. Yes, and that's what it does. So please continue.
Okay, thank you. And yes, as Dr. Anna's introduction is like we just use this method to perform the digital to the analog single convert, and we can plot our second figure. Then we can name it as the figures 2. Plot STX. We can see it on. And we get the labor with labor for the X is the time units, and for the Y is single. X labor. Okay, that's right. And we will get 2 figures like this one. And for the first 10 samples, we can see here from the 1 to the 10, it will be like 1 1 and 0 and 1 and so on. So it will same with the after the convert to the analog single, it's same. For the 100, it will be the 1, and for the this one for the 3, and this is the 300 will be the 0. It will be the same, just like to the digital single already convert to the analog single. So let's go back to the here guidance, and we will come back to the third task and introduce the adaptive white Gaussian noise to the single with the 20 dB single noise ratio, and we need to plot the result. Let's go to the third task. Before we use this command, we must still load this packet. So let's do it. Like it will be and the package communication. And we can load in the command window. We can load it in command window. It's success. And here we go back here, and afterwards, then we will build in the function with this adaptive white Gaussian noise function can be used with the specific single noise ratio value. And we can come back to the documents here. No, here we have this one. Okay, we can help it. Help. And here we are some introduction with here, and with the input X and your single and the signal you can be specified here. And let's get to work. So we define the signal will be the 20, right? 20 signal will be the 20. Can add this one here. Yes, will be the 20. And we use this function to define the received single. Yes, use this function AWGN is the transmitter single as TX and we save it as the figure 3. Plot received single, how it will looks like. And you can see here, we combine with the second. Here, this one is our transmitted single. This one is our received single. And you can see here with a lot of the noise around the samples, but it's almost good because we still can judge that here is 1, here is 0, and with the different, we can understand or the machine can understand that here is 1 and 0. It's almost looks good. Look back to here, and it will looks like this, and we can, and my result is similar with the guidance. Next, let's go back to the task 4. We need to create a simplified single detector with a threshold of the 0.5 voltage, and we need to plot the detected single. And for the guidance, we can see here the detection detection of the single is performed by comparing of the noise value with threshold of the 0.5. So here will be the threshold 0.5. If the detect single over the 0.5 threshold, we can consider it as 0. If it's below the 0.5, we can consider it as the over the threshold, we can consider it as the 1, and below the threshold, we can consider it as the 0. And so we can do it. And usually, if you understand, if we can do, usually we can use the if-else method, like for we can use the for function, like for k equal to the 1 to the nth is Rx, and if the S x of the k get the index from bigger than threshold, then bigger than threshold, as SD detective k will equal to 1, else SD k equal to 0. And this is most usual method we can define in here, but in the Octave there were more convenient method. We don't need to write a loop function, and we can use the we can firstly we can define the threshold, and it will be the 0.5. So how to get this value? We can use the maximum and the minimum their difference to divide into the two. Then we can get the 1 plus 1 minus 0 and divide into 2, and we can get this threshold 0.5. Let's do it. We define the threshold equal to the max our transmitted signal minus the mean transmitted signal. And divide into 2. Then we can hold it on. And we can plot it. How to plot it? We must we hope. Let's do it. It will be from the 0 to the length of the received signal as Rx. And threshold to the threshold. And don't forget the label. On the X is time unit. For the Y label, it will be the single. Let's see how it will look like. Yes, from the figure 3, we have the threshold, and it will remarked here 0.5. So it's done for the first task, and we already plotted the detector signal, and it's a line, and then we can go further for the next task. We'll compile the detection result with the transmit data and see if there are any transmission problems. Here. Code number 5. Yes, here, and you will get some. Basically, it can be how to say. Here is this one is the transmit signal, and this one is the receive signal. Here is the threshold, and we can see from here, and almost no package will get can be separate words. And if here the signal over the 0.5, and it can be considered as the 1. If it's below the 0.5, it can be considered as the 0, and almost good here. So we can go to the next task. We will go to the repeat step 3 to 5 and for different signal value of the 10 dB. Let's go to do it. We only need to change the signal value here 20 to the 10. Then we save it and run it again. Here, this is our randomly generated symbols. Here we have 10, and for the 5, 6, 7, this is 0, and the others other numbers they are all 1. Here, this one is transmitted single, which will same with this one. And we can say for the noise, we hold the here we hold this one, and the noise for the single noise ratio it's 10, and we can the threshold how to say it's hard to can be it's bad, it's really bad, because a lot of the single is close to the threshold, and it's hard to separate them, and it will cause lots of the errors here. So if from the single noise ratio decrease, and the errors also will go increased, and we can go to the next task. We need to convert single to the NRZ and the Biplo pulse single, and NRZ, which means the here and repeat the step 6 with the 10 signal value. That will different with the here from the 1 and 0, and we can see the guidance here. Yes, for the NRZ, and we use the 1 use as the -1 level, and 0 will be the +1 level, and how to convert it. And we just used a formula y equal to the kx plus b, and the very common formula to change it. And we multiply the -2 and +1. Then we can change the 1 matched with the -1, and the 0 matched with the +1 voltage level. And if here we can see here, the threshold also need to be changed, because the -1 and plus the no, the +1 minus the -1, and divide by the 2, and the threshold will be the 1. So we also need to change the threshold, and let's do it. And
sorry, the threshold is 0, I believe, not 1.
Oh, okay. Let's see. Third, and the first task. We haven't deployed the detector single. I think the detector single will be the SD. And the threshold we haven't we already have the threshold, just the receive single bigger than the here. Then we figure 4, but and the plot detect single. Great. And we just copy here x, y label, they will be same. Now we can see here. Yes, here this will detect single, and here you can see for the noise 10 it's really bad, and here figure 4 will be the received single, and figure 2 is transmit single. We can see here, and there were lots of mistake here. But if we change the signal with the 20, oh, I've got it. Let's do it again, and we can randomly generate.
I think you have missed hold off. You have activated hold on, but you didn't never turn hold off.
Oh yeah.
So that is why it's plotting each time you generate
yes.
it plots over on top. So you can put hold off and it will correct itself.
Okay, but we can see here the difference with the figure 20 is inner, and here this one figure 2 is the transmitted single, and figure 4 is the received single with 20 thinner, and it's recovered all the samples, and it's quite good. Here we hope the hold down and hold off here. Okay, so we can go to the next for here, and to change the we change the another modulation method to NRZ, and we can use the function to so here use this function to change the from here from the 1 to -1, 0 to the +1, and we can add the same as this one will be the first task, and this one will be the fifth task. And we already get the received single, the -2, tied with the transmitted single. Then we +1. And the threshold will be the STX transmit single minus the max and we don't need to add more. We just copy it to the to the third task before, and STX here, or sorry, it will STX plot here. Yeah, we just add here STX in here, and we change the threshold here. Okay, and we plot RZSD will be the change the also bigger than threshold hold or the smaller than threshold hold. What will looks like. Some error happen here. Sensor. Bigger for X. Okay, we can save it. No.
So yes, this is what I was talking about, that you cannot start the name with digit. I don't know why it was working before. Honestly, I was surprised it worked, but it seems that now Octave decided that it will no longer work. So you should start with digits, or not digits, but letters. I mean, sorry, with letters, your file name.
Okay. Like
that should work. So yes, MATLAB and Octave in this regard are very
SPX.
picky. Yes. You have missed their multiplication sign, I think. There should be
Here?
Multiplied by STX, yes. And also, I have seen that in threshold, you have used maximum 2 times. So there should be one maximum and one minimum.
Okay, sorry.
No, it's okay, I understand you are worrying your first time ever teaching anybody, so it's okay.
Okay, let's see. And this is the 20. And here we see the noise with the single. And here is transmitted single here with the noise with single. And we know that the single noise ratio is 20 here. And here is the received single if we compared with the second with the transmitted single. Here is the received single. They are all same. That is quite good. And we change the single noise ratio here. We add the 10. And here you will see. And with noise, it looks like how to say. It looks quite a much better than the previously. We used the other modulation method, and almost good. And we see the received single. Yeah, it also can receive the received samples are same with the the transmitted singles. So it looks like we can let the signal be the smaller, like we checked for the 5. How it would. And the transmitted single. And here this is the with noise, and we can see many of the samples they are already close to the threshold 0. And let's see the receive single. And now we can see and many of there are some error samples occupied, and we know, but I don't know if you remember, we previously we used the other modulation method that we used the signal with the 10 is already generate a lot, so it cannot recover the single. And I think you already have the you already know, and you can answer the final questions, the noise immunity of these two modulation types. Which one is better? You already know. which one is better as our lots of the tests or trains. And I think that's all. And thank you. Thank you. Thank you, Dr. Ennis. That's all.
Okay, thank you. And hopefully you weren't just too worried and too uncomfortable for your first time. It was a little bit unexpected for me today that you will be ready today, but it's good that you are so willing to share your knowledge as well. Also, I wanted to tell that I have, while we were having this practical exercise, I have uploaded the playlist for previous year's course, because considering that now we will have a little bit different practical exercises, maybe I thought it would be convenient for you to have access to all materials at once. Yes, here you can see all these materials we'll be working on. Of course, each year is a little bit different, but other than that, you can use these materials. I have put this link. So this includes also practical exercises. So if any moments were not clear enough, you can watch previous year's record. That will also provide some answers there too. But I think that Tiahua did a good job with this practical exercise, especially for his first time. So if you have any questions, please don't hesitate to ask me or him also. He is also in Teams in this group. So, yes. And next week we'll have, again, lectures. But I think we don't have practical exercise next week. So there will be delay. So let me see fast the previous year's course. We'll stick to the same plan. Yes, sorry, this one. And in the previous year, we had first week without practical exercise. Then we had, this week we have practical exercise. Then we have only lectures. And here we'll have practical exercise. Oh, okay, understand. In this week, I will tell you about course projects. So on the third lecture, we'll discuss our course project. You will have your tasks for course projects. I will share some information about it for you. So I will prepare your individual parameters as well by the next week, and we'll on third lecture discuss our course project. So yes, thank you for your attention then, and see you next week.